Alright guys, welcome to your Princeton Review Week 2 help video. Let's go ahead and begin here. I'm going to be doing every other problem. The ones after every problem that I do, those will be pretty much of the same sort as the one immediately before them. Alright, so I'm going to do number 1 and I'll let you guys do number 2. Make some space for me to write here. Alright. So it says use the limit definition of a derivative to find the derivative of each function below. So the limit definition of a derivative looks like this. Okay, this is what's called the difference quotient. It represents the slope formula, or the average rate of change, and as you let x approach h, this point and this point become the same thing, and you ultimately end up with a common answer there. And you know what, I just goofed. That's not right. It's not as x approaches h, it's as h approaches 0. And that makes a lot more sense. Because if h approaches 0, then this goes away, right? And then those two things would become the same, right? And that's the goal. So you take a difference quotient, which is 2 points and the slope between them. You find the limit as the h approaches 0, and then it becomes 1 point. And that will tell you the instantaneous rate of change at that point. So we need to use this limit definition to find out what this derivative is. So first of all, we need to figure out what is f of x plus h. F of x plus h is what you would get if you took your function and you plugged in x plus h for the x. Now, there's a couple ways you can handle that. One way is you can FOIL it out. X plus h squared, that means x plus h times x plus h. Or you can remember I gave you guys a little shortcut formula for that, which looks like this. But if you did it the long way, then you'll still get the same answer. And then we're going to go ahead and distribute that 8 inside. So that's the first thing you're going to want to do, is you're going to want to simplify the f of x plus h expression. Alright, the next thing that we'll do is we will plug everything into our derivative formula. Oops, having some technical difficulties, just a minute here. Okay. So now it's going to be the limit as h approaches 0. And I'm going to put this entire thing here where the f of x plus h goes. That in parentheses. And then minus f of x, which we already know up here. F of x is 8x squared, so that's easy to just toss right in there. And then h goes on the bottom here. Next, we're going to combine like terms in the top. The 8x squared and the 8x squared here cancel because they're being subtracted. And now we have all left on top there is a 16xh plus 8h squared over h. And when you divide this h into the top, it's going to cancel one h out of each term and cancel it out of the bottom, leaving us with 16x plus 8, h I should say, 8h, my bad. And then the last step is to plug the 0 in for the h, and that just leaves you with 16x. Okay, so you do need to show your work for these. I know that there's a shortcut for it. That's what we learned in the beginning of the year, right? We could jump right to that by just multiplying the 2 to the front and taking 1 away from the power. But we're not supposed to do that. We're supposed to be using the limit definition of a derivative to do it. So I would need to see your setup and your algebra that leads to that final answer there. Okay? So that is using the limit definition of a derivative to find the derivative of the function. Let's go ahead and take a look at the next set here. I'm going to leave you guys to do number 2. On the next set here, part B, I will do the first one once again, and I'll let you guys do the second one. Okay. Now this one's asking us to use the alternative form of the limit definition of a derivative. And we use that anytime they're asking us to find not just the derivative, but the derivative at a specific point. In this case, x equals -3. You could do that with the other one too. It's just that the alternative form lends itself quite nicely to that. It looks like this. Where c is the number that they're asking you to plug in for x. So my c value in this case is -3. So this is going to look like the following. So on the top, that's going to simplify into f of x, which we know is 5x, minus f of -3, which I haven't found out yet. So let's do that. How do we find out what f of -3 is? You just plug it into your function, which is 5 times x. So that would be -15. Now the double negatives obviously are going to become positive, so let's go ahead and write that. Now with these ones, a lot of times what you're going to have to do to simplify the answer is you're going to have to factor and then cancel. So in this case, the top, you can factor out a 5. And then you're going to cancel, and that removes the discontinuity. And usually at this point what you do is you'd plug the -3 in for x, but as you guys can see, there's no x here. And when that happens, you're trying to find the limit of a constant function, which is 5, and the limit of a constant function is just what that constant is, so the answer is 5. Okay, so once again, I would need to see your setup and the algebra that leads to the outcome. All right, the rest of it is in your Princeton review book. So let's go ahead and I'm going to do number 1 from each of these sets. So let's go ahead and turn our attention to page 221. Okay, let's read our problem here. Oil spilled from a tanker spreads in a circle whose circumference increases at a rate of 40 feet per second. How fast is the area of the spill increasing when the circumference of the circle is 100 pi feet? So this is a related rate question. It's where you have two rates that are both changing and they're related to each other, and your job is to use one of the rates to find the other rate. So the first thing you want to do is draw a picture. So we're talking about oil being spilled from a tanker and it spreads out in a circle. They tell us that the circumference is increasing at a rate of 40 feet per second. So we'll call this R to represent the radius, and circumference is the distance around the circle. Now, if you guys don't know, this little formula will come in handy later. The circumference of a circle is 2 times pi times r. All right, and it's just basically the measurement of the length outside of a circle. Next, it says, how fast is the area of the spill increasing when the circumference of the circle is 100 feet? All right, so the next thing we're going to do is we're going to identify the given rate. So the rate that they gave us is how fast the circumference is changing. So we're always going to put d over dt, and you could pick whatever letter you want to put here, so long, I think you just want to pick a letter that represents what we're finding the rate of. In this case, we're finding the rate of change of the circumference. So I'm going to put dc dt, and that represents how fast the circumference is changing. And they tell us that it's changing at a rate of 40 feet per second. Okay. Now, what they want us to figure out is they want us to figure out how fast is the area changing. So find. They want us to find dA dt. How fast is the area of this circle increasing? Now, area is measured in square units, so that's going to be square feet per second. Now, you guys can imagine that if your circumference is increasing, because that's a positive rate, correct? Then your area is going to be increasing, so that's going to be a positive rate. Keep in mind little details, like if they said something was decreasing, like let's say instead of saying the circumference was increasing, they were saying that the circumference was decreasing. If they say that, then you need to put a negative here. So watch out for little details like that. Okay, now the next part of this problem is going to prove to be a little bit tricky. We need to find a formula that connects C with A. All right, well, that's a little bit tricky. I've got a formula that connects C to R, and you guys might remember how to find the area of a circle. Area is pi r squared. So I've got a formula that connects area to radius. So these guys are connected somehow, right? If the circumference is connected to the radius and the area is connected to the radius, well, that would mean that somehow the area and the circumference have to be connected to each other. So I'm going to show you a nifty little move to create a formula that will connect our two variables, the variable that we have and the variable that we want. Okay? So here's how you do that. Let's solve this formula up here. Let's solve for r. So I'm going to divide both sides by 2 pi. Now, why did I do that? Well, now that I know that r is equal to c over 2 pi, then I can take this formula here, area equals pi r squared, and I can replace the r with what r equals. So how did I know that I needed to do that? Well, I know that I want a formula that connects C and A. I had a formula that connects C to R, and I had a formula that connects A to R. So I eliminated the R by substituting it with something that has a C in it instead, and that way we get a new formula. It's a little bit tricky, but now a lot of times they're not that tricky, but this one was a little bit tricky. So, but anyway, let's go ahead and simplify this a little bit. First of all, if you square the part in the parentheses, you're going to end up with C squared over 4 pi squared, and then this pi is going to cancel out one of the pi's on the bottom, and so you're going to be left with C squared over 4 pi. So the formula that we're going to use is area equals C squared over 4 pi. Now I'm going to rewrite it a little bit also like this, just so it's a little bit less awkward to use, because that 1 over 4 pi is really just going to be a constant multiple, and that's going to be helpful to have it written like that for our next step. But let's review really quick. So step 1, draw a picture. Step 2, identify your given rate. Step 3, identify what rate you're trying to find. Step 4, find a formula that connects the variables that you care about, in this case C and A. So we had to be a little creative and create our own out of the ones that we already do know. All right, let's move on to the next step. Step 5 is to take the derivative of that formula. Find the derivative of your formula. So I want to take the derivative with respect to time of my formula a equals c squared 1 over 4 pi in the front. Okay, so when we're doing this, the derivative of a with respect to t is going to end up being dA dt. And this, when I take the derivative of this next part, it's going to be kind of like a chain rule. We have 1 over 4 pi times c squared, where c is kind of like an inside piece. So when I take the derivative of this thing, the derivative of the outside is going to be a power rule. You're just going to take that 2 there and you're going to multiply it by the pi over 4. And so that's going to give me 2 over 4 pi. And then you're going to subtract 1 from your power, leaving it as a first power, which you don't really need to write when it's a 1. And then we'll put our c back in there. But since it's a chain rule, we're going to multiply it by the derivative of c with respect to t. Now we can simplify this. That could be rewritten as 1 over 2 pi, right? So let's go ahead and do that. All right, and then the next thing we're going to do for step 6 is we're going to plug in everything that we know to solve for what we don't know. Okay, now remember, my goal here is I want to find out what's the rate of change of the area with respect to time. Okay, so we want to find out what dA dt is, so I'm going to leave that as just a variable because I don't know what that is yet. 1 over 2 pi is going to stay. But I need a circumference. Did my word problem give me a circumference anywhere? It tells me right here that the circumference is 100 pi feet. So I'm going to put that right in there like that. Next, we need to find out what's the rate of change of c with respect to time, which we have right here. So I'm going to put a 40 in right here. And then all I have to do is simplify. So the pi's are going to cancel, and the 2 can go into the 100 50 times. So all I'm left with is 50 times 40, which is about, what, 2,000? And we decided that was going to be feet per second when we were all done, or square feet per second. And there's our final answer. So this one was a little bit more challenging than just a basic example because of step 4. Okay, but let's review. Draw a picture, find your given rate, identify what rate you want. Based on those letters, you need to find a formula that will connect those letters together, and that was the tricky part of this problem. The next thing is we're going to find the derivative of it, and you're going to end up doing a chain rule, so don't miss that out. Don't forget to include that dc dt in there. And then finally, you just start plugging in everything that you know so that you can find the one thing that you don't know and you're trying to find. Now for number 2, which I'm going to leave you guys to do, it's a lot more like the ones we did in class. Step 4 will not be quite as tricky. Let's go ahead and take a look at our next problem we need to do. We want to go to page 226, and I'll do number 1 on that page. All right. So says find the velocity and acceleration of a particle whose position function is given by this. So this is a function that will tell me the position of my particle at any given time. So for instance, let's just say that time is measured in seconds, and let's say you plug in 0. If you plug in 0, you're going to get 0. And so what that means is that at t equals 0 seconds, my object is located at, or I could say the particle is at x equals 0. When I plug in 0, I get 0. Now, if you want to find the particle's position after 5 seconds, you could plug in 5, and it will tell you how far along the particle is at that point. All right? Now, that's not what the problem's asking. I'm just helping you interpret what we're looking at. What the problem is asking us to do is to find the velocity. The velocity is the derivative of the position function. The acceleration is the derivative of the velocity function. So if this is the derivative of the velocity function and I take the derivative of that, I end up with a double derivative. So acceleration is a double derivative, velocity is a primary derivative. So pretty simple. We're just going to take derivatives here, but you have to understand the definitions and how the terms relate to each other. So there is our velocity function. I'll put v for velocity, and then a for acceleration would be that. Okay, I'm going to let you guys do number 2. Be aware that you're going to have a chain rule going on right there. But let's move on to the next page. I think it's our last page. Page 252, number 1. Find the limits using L'Hopital's rule. So with L'Hopital's rule, the first thing you're going to do is you're going to do direct substitution. So you're going to plug 0 in everywhere there's an x. Now 0 times 3 is 0, and sine of 0 is 0. The same thing happens on the bottom. So direct substitution yields the indeterminate form zero over 0. Now we have to write that because that's our green light to say, okay, cool, I can use L'Hopital's rule. You're not allowed to use L'Hopital unless direct substitution gives you 0 over 0 or infinity over infinity. Now, what you don't want to do, by the way, is you don't want to put equals 0 over 0. We talked about that. 0 over 0 is not a number, and so you can't say that it equals that. Instead, we'll say that direct substitution yields the indeterminate form 0 over 0. And then we say, therefore, by L'Hopital's rule, oh, they're not putting an S there. I don't know how to spell it. I could swear I've seen places spell it with an S. Oh well, who cares? I don't think you get downgraded for that on the AP exam, so don't sweat it. But anyway, therefore, by L'Hopital's rule, the original limit, so I'm going to rewrite that really quick, the original limit is equal to the limit of this following new function, which can be found by taking the derivative of the top. Now that's a chain rule. The derivative of sine is cosine. And then the derivative of the inside is 3. And same thing on the bottom. Derivative of sine is cosine. And the derivative of the bottom is 4. And then we do direct substitution again. Now if you get another indeterminate form, you just do L'Hopital again. But in this case, that's not going to happen. If you plug in 0 for x, 3 times 0 is 0. Cosine of 0 is 1. And 1 times 3 will be 3. And on the bottom, cosine of 4 times 0 is going to be 1 times 4, which is 4. So the final answer is 3/4. Okay, so let's review. Step 1, direct substitution, make your statement. Step 2, state that the original limit is equal to this new limit, and then find the answer. And that's L'Hopital's rule. I'm going to let you guys do number 2 on your own. All right, hope that was helpful. We'll see you guys in class.